Now, good morning, learners, and welcome to my topic here on atomic structure and periodic table. Now, in the first lesson of this, I will be looking at maybe some few concepts I learned already, so that maybe we can be able to transit to our topic here. I'll be defining an atom. This could be the second time we'll be doing this. I'll discuss the subatomic particles of an atom. That is, the particles within an atom. I'll then look at maybe the structure of an atom, and maybe finally here I'll be looking at the electron configuration. Now, the topic itself here, you can actually be able to see that I'm just talking about the structure of an atom. There's atomic structure. And finally, I want to look at maybe the periodic table, a periodic table. We'll get to these, but basically we'll talk about a table here, a periodic table here. We're talking about the table of elements, which will be arranged based on the atomic structure. We'll be looking at that based on atomic structure. That is, for instance, how many protons are there in that particular atom, and the like, and how many electrons are there maybe in the outermost energy level, and so on and so on. We'll get to this. Now, on to my first point here. Can have just a brief introduction of this topic here. And let me say this, that so far, in our past discussions, we've been able to look at the properties. If we go back to our definitions of chemistry, we remember having mentioned, we mentioned here that chemistry is a study of the properties, the structures, and the composition of matter and the changes that matter undergoes. Now, we've been looking at properties. And as far as the properties are concerned, we can actually divide them into two here. We can talk about the physical properties. Now, physical properties, these are things that we can see actually. We can talk about things like the melting point, for example, of a substance. We did look at this some time back. And we mentioned here that as far as these physical properties are concerned, like, for example, the melting and boiling point, we must have mentioned that it is actually about the intermolecular forces joining the particles together. But when we came back here, or when we learned about the reactivity series, when we were discussing about the reactions of metals with water, we were able to note that some of these metals here will react vigorously. They're going to react vigorously with water, while some, you would even realize that maybe they would not react with water. Now, this is what it is here. When we talk about the reactivities, or when you talk about one element combining chemically with another, then we talk about the atoms. And therefore, if we are to understand exactly what happens during reactivities, then we must discuss about the atom. And more so, we look at the subatomic particles of an atom. That is what we actually are talking about. So, in this acute topic here, by the end of this topic here, you need to actually be able to understand or to explain why a given element is more reactive than the other. Why a given element here is more reactive than the other, and so on and so forth. At the same time here, maybe trying also to draw the structures of atoms. And after that you can also be able to predict the behaviors and most of the properties of that particular element. That's what I'm talking about. So basically that's what we are talking about. as far as, or maybe what we can talk about as far as the introductory part is concerned, as far as the introductory part is actually concerned. Now, on my second point here, let me take you through the definition of an atom here. So an atom here may be defined as the smallest particle. The smallest particle of an element that can take part in a chemical reaction. This is an atom. This is actually an atom. An atom may be defined as the smallest particle of an element. If you think about an element here, the simplest unit of it, or the basic unit of it, is actually an atom. Is actually an atom here. The most critical thing here is that can take part in a chemical reaction. Therefore, every time you think about an atom, it is important you think about chemical reactions. It's important you think about the chemical reactions. Now, it's important to mention here that maybe in Form 1 again, we did mention about the particulate nature of matter. Particulate nature of matter, that matter is made up of small particles, and according to kinetic theory of matter, we mentioned here that the particles are in a constant random motion. They are in a constant random motion here. Now, when we talk about the particles here, we can talk about the atoms. I think it will be important maybe to mention this here. We can talk of an atom. At the same time, these particles can be molecules. It's important to mention that one again. They can be molecules. We'll also be discussing what molecules are later on here. And of course, I think we still know here, or we can just mention it, that maybe a molecule is another, it's also the smallest particle of an element or a compound that can exist separately, because it is stable. Now, and of course, we can also have an ion. We also have an ion. When we talk about the particulate nature of matter, matter can also be made of particles that we call ions. Again, we'll be able to look at that. But my interest in today's lesson here will be looking at an atom. Now, very fast, let me take you through the subatomic particles in an atom. The subatomic particles in an atom here. So this one here, we've done some small introduction. The definition of an atom, there we have it. Then we talk about the subatomic particles of an atom here. Subatomic particles of an atom. Now, as far as an atom is concerned here, we are going to have 3 subatomic particles. These are particles that we find in an atom. Now, let me start by discussing about the first one here that we call electrons here. Now, from these electrons here, you can see the word is looks like some more of electricity. Now, when you think about electricity, the electricity actually, we normally say, on electric current is actually a flow of electrons, and therefore, when you talk about electricity here, it has to do with electrons. And I think it's important to mention here that every time you hear, for example, a substance is conducting, especially metals, when metals are conducting, they will do it using electrons. They are going to do it using electrons. Now, what are these electrons here? Now, what are some of the properties of these electrons, these particles actually in an atom? How are they like? Now, one, they are negatively charged. This is something about the electrons. They are negatively charged. They are actually negatively charged. Therefore, you can talk about them being charged particles. They are actually charged particles here. Those are electrons here. Now, one other thing about electrons here is that they have a negligible a negligible mass here. They have a negligible mass. And now, if we were to talk about the mass of an atom, then you should not include electrons because they have a negligible mass. And maybe if we talk about the mass, therefore we can only talk about other substances. We can only maybe talk about other substances. That's what we are talking about. Now, maybe number 2 here, I can mention about the protons. Now, protons here are actually positively charged. They are positively charged here. Positively charged particles. And this ones here, unlike maybe the electrons here, they have a mass here. They have a mass here. We can talk about have a relative atomic mass of 1. A relative atomic mass of 1. When you're talking about the masses of these atoms here, an atom is very, very, very light. We can talk about billions of a gram. And therefore, for this one, we're going to use a unit like relative atomic mass, which is more of a comparison. Now, the third subatomic particle in an atom is neutrons. Now, neutrons here, they are neutral. They are neutral. Neutrons are neutral. And maybe the neutrons, you can actually see maybe in those words there's some connection here. They are actually neutral. And this one, so they have a mass, have a relative mass unit of 1, just like a proton, And therefore, maybe when you talk about the mass of an atom, we will actually be considering the neutrons and the protons. We're going to look at the neutrons and the protons. And basically, those are the 3 subatomic particles that we can talk about in an atom. Now, let's have a look at the structure of an atom. The structure of an atom here. Now, an atom here, an atom may be said to have 2 regions. Here. Now, we have the innermost region here, and then we have the region outside this. Now, the innermost region here, we actually call it nucleus. Here. Now, outside the nucleus here, we are going to have another region here. Now, this region here, will consist of what we call energy levels. Will be called energy levels. And therefore, in this particular region here, we may have some energy levels. We are going to look at maybe what energy levels are. Now, if I talk about simply about the energy levels here, the energy levels are basically the possession of electrons. Now, the electrons here, we are going to find them outside the nucleus. Here. And there will be their positions here. The positions of these electrons is what we actually call the energy levels. We are going to call them energy levels. Now, this is what we're talking about here. Now, this one here forms the energy levels. We're going to call them energy levels. Now, let me try and maybe discuss or maybe put, we note a few things as far as the nucleus is concerned here. Now, in this nucleus here, this is where the neutrons and the protons are found. the nucleus here contains neutrons and protons. And having heard of this here, of course, if you talk about the nucleus containing neutrons and protons, and then you think about this, the neutrons are neutral, and the protons are positively charged. What does that one tell you about nucleus? That the nucleus here is positively charged here. Of course, we understand that the protons cannot be neutralized by neutrons. The protons here are positively charged. Particles can only be neutralized by electrons. And therefore, because the electrons will be found outside the nucleus, they may not neutralize these protons actually. And therefore the nucleus will be positively charged. That's what we are actually talking about, of course. Now, we can also be able maybe to say that the mass of the atom here the mass of the atom concentrate or is concentrated in the nucleus. In the nucleus. That is what we can also say. So when you think about the mass of an atom, it is actually concentrated in the nucleus. Why? Because outside the nucleus, when we have the electrons here, electrons, we are saying they have a negligible mass. Electrons have a negligible mass, and therefore they cannot add, they may not actually add anything actually to actually that particular atom. We must have mentioned here, when we talk about the negligible mass, actually we are talking about a 1/1840 relative atomic mass unit. That is 1/1, almost 2000. 1/1840 over proton or over neutron. That is the mass of electron, which is actually negligible. That's what we're talking about. Now, these energy levels here, on the other side here, will contain electrons. They will contain electrons. Now, these electrons here, this is what we're talking about. They contain electrons. These electrons here, the electrons containing the same energy will be in the same energy level. That is what we're talking about here. That which are arranged according to the energy. According to their energy. That's what we're talking about. So these are energy levels. These are actually energy levels. Contain electrons which are arranged according to their energy. Now, electrons possessing the same energy will be in the same energy level. Now, others again, maybe in the second energy level there, again we're going to have electrons having the same energy. That is what we are talking about. Now, as far as the energy levels are concerned also, maybe you can also mention here that can only hold Now, when you talk about these energy levels here, each energy level can hold or holds a maximum number of electrons. That means here that at a certain level, an energy level cannot hold more than the expected number of electrons. For example, the first energy levels we're going to see here can only hold 2 electrons. The second one can hold 8. The third one can also hold 8 as far as the first 20 elements are concerned. That is what we are actually talking about. Now, so basically that is what we can say about the energy levels. Now we get to the electron configuration. And we see exactly what we're talking about. Now let's have a look at maybe the electron configuration here. We've just mentioned here that in the structure of this particular atom here, we have the nucleus and we have what we call the region outside the atom, which basically forms the energy levels, which actually form the energy levels. Now, in these energy levels here, we have the arrangement. You know, we have the arrangement of electrons in an atom, or in the energy levels. Now, the arrangement of these electrons in the energy levels here is what we actually call the electron configuration. Is what we call electron configuration. Now, maybe as far as this one is concerned here, the number of electrons in the energy levels here can be determined by the formula 2n squared here. Now, where n here is the energy level number, here, energy level number. For instance, here, if you talk about the first energy level, the first energy level here will hold 2 times 1 squared here, which are 2 electrons. Now, the second energy level will hold again 2 times, this is the second energy level, therefore n is equal to 2 here. So n squared here, 2 squared here, which will be 2 times 4. That means that we're going to have 8 electrons. The third one, you can tell here that we'll have 2 times 3 squared. Now, this one here would give you 18 electrons. But get this here, very important here to note. Very important to note here. As far as our first 20 elements are concerned, because our study on this here, maybe we'll in the high school, maybe we're going to look at the first 20 elements. Now, for the first 20 elements here, our third energy level here will be assumed to have or to contain 8 electrons. Get note of that. Will be assumed to contain 8 electrons. Will be assumed to contain 8 electrons. So basically, this is what an electron configuration is. Now, it is important to note here that we cannot have electrons occupying the second energy level until the first energy level is full. So basically what happens here, the first 2 electrons here will occupy the first energy level. And then the extra electrons get to the second. And again, if we have more, then they get actually to it gets to that energy level. So basically this is what we're talking about here. Now, an element or an atom here with 1 or 2 electrons will only have 1 energy level, because the 2 electrons or the 1 electron there will just occupy the first energy level. Now, any atom with more than 2 electrons here will have more than 1 energy level. Now, an atom again with more than 10. Remember, the first one occupies 2. The second energy level occupies 8. Those are 10 electrons there. Therefore, any atom here with more than 10 electrons will definitely occupy or will have the third energy level. Then, of course, we've just mentioned here about the third energy level, and please get note of this. For the first 20 elements that we'll be discussing here, the third energy level here will hold 8. So please get note of that. We'll hold 8. So let's assume this one here. Let's forget about this here. We'll have 8 electrons. We're going to have 8 electrons for the first 20 elements. Here. First 20 elements, of course, we're talking about elements here with protons of 1 proton up to 20 protons, or 1 electron up to 20 electrons as far as the atoms are concerned, because electrons and protons are actually equal. That's what we're talking about. So basically, that's the electron configuration, and by now here we can now be able maybe to draw the structure of an atom, having known how to represent the electrons in the energy levels. And again, we also know that maybe in the nucleus we have the protons and we have the neutrons. We have the protons and we have the neutrons. Now let me now let me have a question here that will help us to understand exactly the electron configuration or the electron arrangement. Write the electron configuration of the following atoms. We have, let me use sodium. Now sodium here, you're given that it has 11 protons, it has 12 neutrons, and of course our interest is actually the electrons. It has 11 electrons. Now with 11 electrons, therefore, let's see how do we present, how do we write, what will be the electron configuration of sodium? What will be the electron configuration of sodium here? So our interest here is electrons. Our interest here is electrons. Now let's think about this. Now the first energy level will hold 2 electrons. Will actually hold 2 electrons. That's the first energy level. Remember, I am presenting 11 electrons. Now this 11, the remaining electrons after we have 2 in the past, we are going to have 11 minus 2, 9 electrons are remaining. Now the second energy level can actually hold a maximum of 8. So 8 of the remaining 9, of course, get to the second energy level. You're going to have, therefore, 2, 8. And once you have 2, 8, this are already 10 electrons. So with 10 electrons, we have 11 minus 10, remaining 1. And therefore, we are going to have 1 in the outermost energy level. We are going to have 1 in the outermost energy level. That's what we're talking about. Now, we can proceed like that. We can have something, for example, like aluminium. Or let me mention maybe something that has maybe 2 energy levels. Maybe we can talk about something like fluorine. Let's think about something like fluorine here. Now, fluorine here has actually 9 electrons. It has 9 electrons. 9 electrons here. That means that we've seen the number of electrons equals the number of protons. Therefore, I also expect 9 protons. And we'll have 9 neutrons. We'll also have 9 neutrons there. 9 neutrons. Let's look at that. Let us have a look at that there. Now, in this particular case here, if we were to write the electron configuration of this here, our consideration again is 9 electrons here. So what will happen here? The first energy level, as usual, will hold 2. Will hold 2 electrons. The first energy level holds 2 electrons. Now, how many remains? How many remains after 2? This is 9 minus 2, 7 remains. 7 electrons remains. And because the second energy level holds a maximum of 8, that means the 7 remaining electrons will get to the second energy level. And therefore, that will be the electron configuration of fluorine. That will be the electron configuration of fluorine. Maybe we can have the last one here. We can think about potassium. Now, potassium here will have 19 electrons. Of course, 19 protons. Get note of that. The number of electrons and protons here are always the same. And maybe we're going to have 20 neutrons. Think about this here. Now, let's talk about that. Now, with 19 electrons, of course, the first 2 electrons occupies the first energy level. Then we're going to have a 2 there. Then, of course, with the 19 there, we are going to have how many remaining? Of course, we have 17 remaining. 17 remaining. The second energy level holds a maximum of 8. So I've already have 10 electrons here now. How many remains? 19 minus 10 here. 19 minus 10 here. I have 9. Therefore, again, 8 of the 9 occupies the third energy level. Please don't forget that I've just mentioned here that for the first 20 elements here that we've talked about, we'll be dealing with the third energy level here will hold an 8. Now, so far we have 2 plus 8, 10 plus 8, these are 18. I still have 19, therefore 19 minus 18. 1 more remains here, and that one will get automatically into the 4th energy level. And to the 4th energy level. And basically that is what the electron configuration is all about. That is, it's all about this. Now, what can you see here as far as the electron configuration is concerned here? You can actually be able to tell the number of energy levels. The number of energy levels that these atoms will have. You can actually be able to tell that sodium here will have 3 energy levels. The first one occupying 2 with 2, 8, and 1. 3 energy levels. Fluorine here, we have 2 energy levels. With potassium here having 4 energy levels. Now, having discussed the electron configuration, and of course we know basically the structure of an atom, that it actually contains nucleus and the energy levels, then we can actually be able to draw the atomic structures of the elements. Now, think about something like sodium here. Now, sodium atom here will have 11 protons. In other words, the atomic number of it will be 11. We are going to look at this. In Devontree, if the number of protons are 11, electrons are also 11, and it will have 12 neutrons. Now, how do we present this? How are we going to present this? So we're going to have, for example, let me of course the innermost part here, which actually contains, this is a nucleus. So we're going to have our nucleus. It contains 11 protons and 12 neutrons. Please don't forget that the protons and neutrons, we find them in the nucleus. And then now let's think about this sodium again. Let us think about it. Now, if you try to look at maybe this sodium here, it has 11 electrons. Now, 2 of these electrons, of course, will be in actually the first energy level. Therefore, we're going to have 2 there. This is the electron configuration. We are going to have 2. And then in the second energy level, of course, we are going to have 11. Sorry, in the second energy level here, we are going to have 8. Now, I can use the dot here, and we can also use a comma or a full stop. So 2, then 8 electrons occupy the second energy level. Now if you try to look at that there, already I have 10 now. I have 10 and I require 11. 11 minus 10 is 1, therefore 1 remains, and therefore I'm going to have 1 there. Therefore what we can actually be able to tell here is that I'm going to have 3 energy levels. 3 energy levels. One of them, the first one of course has 2 electrons. 2 electrons, we are going to have them there. 2 electrons. I'm going to have the second energy level. I'm going to have the second energy level. The second energy level, and I'm going to have 8 of them. I'm going to have 8 of them. Look at that. I'm going to have 8 of them. And finally, I'm going to have the third energy level, and we'll have 1 electron. I'm going to have 1 electron. So basically, that is what we're talking about. That will be the atomic structure of sodium. That will be the atomic structure of sodium. Maybe we can also have one more here. Let's think about one more. For example, we can think about fluorine. The chemical symbol of fluorine is F. That of sodium is actually capital N, small a. Now with this fluorine here, fluorine has 9 protons. It has 9 electrons, and it has 10 neutrons. Let's think about that. We have 10 neutrons there. Now, with this case here, so let's try maybe let's start by maybe working out the electron configuration of this fluorine. Now, of course, we've said the first energy level holds 2 electrons. We can be able to say that, 2 electrons. And then out of these 2 now, we remain, this is 9 minus 2, 7 electrons remains. And 7 electrons will obviously occupy the second energy level. The second energy level. Now, having said that from there now, then we can actually come now and draw the structure. As usual, our central part there will contain the neutrons and the protons. Therefore, I'm going to have 9 protons here. And I'm going to have the 10 neutrons in the nucleus. And then after that, I'm going to now to draw the energy levels. The first energy level here, we'll have 2 electrons. We'll have 2 electrons. We'll have 2 electrons. I'm using crosses. I can also use dots. Now, then, of course, the other one, the second energy level, will hold 7 electrons. Therefore, I'm going to have again and I'm going to have exactly that. This one is actually the atomic structure of fluorine. This is the atomic structure of fluorine. So basically, this is what we're talking about as far as the atomic structures are concerned. It's just, you just need to present it. You think about what is in the nucleus. This, of course, will be the protons and neutrons, and then now think about now what is outside the nucleus. Those are the energy levels, and with electron configuration, you'll be able to do exactly what you've done. So with the that marks actually the end of our topic, or lesson 1 on our topic, that's atomic structure and periodic table. Now in my second topic here, we are going to further look at some of the terms that we use in defining the atoms. We're going to look at maybe the atomic number, the mass number. I'm going to look at maybe terms like isotopes, and so on and so forth. So kindly don't miss in this second lesson. For I also maybe remind you that kindly subscribe to my channel, like, you can also leave a comment and share. Thank you very much, and God bless.